Hey everybody, Samuel Singer here, the founder and executive director of Wyoming Stargazing. Thanks for joining me, and welcome to Mind Bending Astronomy. In every episode, we'll share with you, a mind-bending fact about astronomy. I have to warn you that our topic for today, quantum entanglement, is probably one of the most bizarre topics that exists, in the entire universe. Just to make sure we're all on the same page about quantum mechanics, let's do a little review. Quantum mechanics predicts lots of totally normal things, like the existence of all the subatomic particles we've discovered so far, the atomic structures of the elements, and the colors that hot things glow. It also makes some pretty outlandish predictions about what's constantly happening at the smallest scales of reality. For starters, it suggests that subatomic particles like electrons or photons really don't exist anywhere until they interact with other subatomic particles. What's even weirder is that those particles can actually interact with themselves, like in the double slit experiment. So those tiny particles are actually more like waves of probability before we make a measurement of them. Quantum entanglement enters a whole new level of weirdness. You see, it turns out that nature loves opposites. For every particle that has one quality, there's another particle that has the opposite quality. What's more is that there are these particle pairs that somehow arrange themselves in such a way that the paired particles always have opposite qualities. As soon as you measure the quality of one of these particles, you instantly know that the other particle has the opposite quality. Enter the Copenhagen interpretation of quantum mechanics that says that tiny things like paired particles legitimately don't have any existence in any particular location or have any definable qualities until you measure them. So, if you measure the quality of one of these paired particles in your physics lab, after you've let its particle pair travel some distance away, then the act of measuring one of the particles instantaneously causes the quality of the other particle to pop into existence. The second particle could hypothetically be on the other side of the known universe. Einstein and his colleagues Podolsky and Rosen thought this was absurd, because it would mean that the particles were somehow communicating faster than the speed of light. To show how ridiculous it was, they even came up with a thought experiment that's become known as the EPR paradox, Einstein-Podolsky-Rosen paradox. Spoiler alert, the experiment has actually been done now several times. It turns out that Einstein, Podolsky, and Rosen were wrong. The spooky action at a distance actually happens. It seems that the law of locality, that things actually exist in one location, is simply not true. Or even more alarming, that the universe actually changes when we make a measurement of it. It might not actually be out there at all. To hear the full story about this, check out the video that I have linked above. Tomorrow, we're going to return to the topic of light and explore why its speed seems to be fundamental with the structure of the universe. Until then, be well and don't forget to look up.